Alright, we had a little difficulty with this project, and this is part of the first quarter work, and it really is the intro and the basis for what you need to understand wiring diagrams, which is what we're all going to have to read when you start installing this heat and air conditioning equipment. Now the reason I like to use the particular wiring diagram that we have up here, which is really, this is a water cooler, but this is not just a water cooler wiring diagram, it also has a heating unit to heat some water too. So this could be used in a multitude of ways. It could be put together for maybe one of the water coolers that you have the 5-gallon bucket on top of, the big drum, and you can hit the hot or the cold. But this wiring diagram is so basic that this one right here, just this cooling part for the refrigeration system, can be used for this water cooler, can also be used for this mini fridge. So it's pretty much the same setup, minus one component for the mini fridge. The mini fridge has one less component than this one does here. Alright, so what you're going to do is first we're going to start off, we're going to identify all the symbols again on this wiring diagram, and we're going to create a legend. So go ahead and take one, pass it back. So this is going to be our wiring diagram. It matches the one that's on the board. Alright, so this has got all our basic symbols, and we're just going to work from the top over. So you see that symbol there? One looks like the Charlie Brown shirt, squiggly line. That can be used first off on the back of the paper, write legend. Or you can write string them, same thing. Alright, yeah. So look at this one here. See that one there with the squiggly lines like that? That could be a lot of different things. But they're using that right here as a heater. But it really is a resistor. That's a sign for the resistor. So that's going to be your heater. Alright. And then we got this in a couple different places. And normally the hot control has the line above the dot, which that dot is the switch, and then this little funky squiggly line underneath attached to it with the kind of looks like three sides of a square. That's the symbol's a thermostat. So that we could call it a hot control, a cold control, but really what this symbol is right here, when they have it going below the screw, it means it opens on temperature drop. So once we get to a cold enough temperature, that thermostat will drop down, open the circuit, and turn the unit off. When it's above the screw like this one up here, that's open on temperature rise. So that means it's going to, when it gets hot, open up and then break the circuit. Alright, so depending on where it's at on the location for the screw, but ultimately what it is, we're just going to call it a T-stat, a thermostat. So that's the symbol for a thermostat. And then depending on where the placement is above and below the screw, determines if it's an open on temperature rise or open on temperature fall, or close on temperature rise. Same thing, they can call that a bunch of different ways. They got one here, I'm not going to draw this one, but this is a manual reset limit. Okay, in other words, it's working with temperature. There's another one that they have that's pretty common in the HVAC field. It's a high pressure limit, but it doesn't deal with temperature, it deals with pressure. And this one you have to manually reset. In other words, if this heater stayed on all the time, you wouldn't want it boiling the water inside the reservoir, because what would happen is it boils water inside the reservoir right here. And it starts building up pressure. What eventually is going to happen? Blow up. Boom. So what this does is this measures when the temperature gets too hot, and it pops the little button up and opens the switch, and by manual, does that mean your switch, manual? No, it's not. No, it means what's manual mean? What's it mean? What's manual mean? Physically got to go hit the button to shut it, to turn it back on. Yep, and then before you're just going to hit the button and leave? What probably should you do? Hit the button and what? We'll figure out why it went off. Figure out maybe this hot control stayed energized too long. Maybe we got a bad thermostat, and you got to figure out why that. Maybe replace the thermostat. All right, but usually if this popped, there's a reason why it popped, and usually something else went wrong. And then you got this symbol right here, the squiggly line. Looks like that. Looks like a sine wave almost. And that one there, it goes. I can take it a little bit further. They got it actually going like this, boom, like that. And what is that? Fuse. Is that manually? What do I got to do if that blows? Replace it. Change it out. Yeah, it's a one-time deal. Now they have another one that's like a circuit breaker that you can reset, but that's a fuse being a one-time deal. And then this one right here, that's just the basic. That's going back to your level 1 project, that first project where it's just a single pole, single throw switch, or we could just call it a switch. And then this one says it's a toggle, so it's not the same type of switch as the light switch over here. Although it looks similar, it's a toggle switch, which means it's got like a little metal piece with a ball on the end. Okay, so that's it. Now, does this look like it has any heater or anything? No. So for the purpose of this diagram, we just went over that to go over some of the symbols and signs. But you don't have to pay attention to that. That's not what I'm testing you on today. All right? But some of the stuff that's down in here is up here. It's the same stuff. Okay. So this is what you're supposed to do. You were supposed to, sometime this quarter, wire up this compressor using this cold. So here's your compressor here. And it's got all the parts to it. There's an overload. I'll pop that cover off. We'll show you the overload. It's got a relay. And then the windings are inside. And then some compressors, like you see this one here, what's that can off to the side here on this one? Because this one doesn't have it. This one does. And it's a starter, but we don't call it a starter. It's on the start winding, which is, but to get it to start, what do we call that thing? Starts with a C. Capacitor. Capacitor. It's our capacitor. So capacitor is optional on some units. Not all of them have it. Okay? Just depends on the type of compressor you have and how much torque it needs to start. Alright, and then you got your windings inside, the overload protector, and the starting relay. And I'll show you all that. But this is the cold control right here. That's it. That's the thermostat. We already drew that. That's up. Okay? Just like for the heating one. This is one. Now the thermostat for this one, right here. I can identify it right here on the water cooler. And look where it goes. Everybody thought this was a refrigerant line that you cut. It's not a refrigerant line. That's the thermostat. That's the actual, we call it the sensing element. It's got a little bit of refrigerant pressure that you remember if you did the third project for electrical back in level 1, you had to hold it. And what happened when you held it?
Kicked on.
It kicked on because it was hot. And then you wrapped it around the snowman, and what happened to it then?
Kicked off.
It kicked off because the pressure dropped. This is using pressure and a little bellows and a diaphragm, just like the regulating tank that we use, right? The regulating valve over there has got a diaphragm. This has got a diaphragm. And it uses the pressure to hit the switch for us, right? And that's all that is. So there's our thermostat there. But where would the thermostat be in the water cooler? Would it be back here by the compressor like this one?
Inside.
No, yeah, I got to go around inside, physically open up the door, and there it is right there. Thermostat's right there. And that sensing bulb, also, like you see this one pushed back into the reservoir, that one's pushed back into the evaporator part of the refrigeration unit to sense the evaporator temperature, so that when it gets cold enough, right, it's a refrigerator. We don't want it below what temperature? Or it should be above what temperature? 20? It's a freezer? 32. 32, yeah, 32 degrees. Because it's not a freezer, although some have a little freezer section in the top. Most of these mini fridges, this one here, it's got a little tiny freezer. So the freezer you want 32, but the rest of the cabinet is probably going to be set at about 40 degrees. Right? So that's that. That's just going to be, depending if it's got a freezer, or if it's just one single fridge, or if it's a combination, or they got them like this that are just freezers. They're a little bigger. But they put those usually in on the garage and stuff like that for extra meat. So that's it. That's all your components. And then this one doesn't have this piece here. What was that? That's our fan motor. And where's it go? In the evaporator or in the condenser for the water cooler? It's this part up here coming right off the compressor. Condenser, yeah. So this is our condenser fan motor. So the single little mini fridge won't have this component. That's the only circuit that's missing. And they can draw that fan motor a couple different ways. They can draw it almost like a little resistor with a circle in it. This one here, we'll go ahead. Let's draw some stuff. So you got the cold control already. All right, you got this thing here. All right, and they can write FM or they can write fan motor, but that's our fan. And then whatever component it's next to, if that was inside near the evaporator, that'd be an evaporator fan motor. This one's out by the condensing coil here, so this is a condenser fan motor. But they're both books are the same sometimes. Doesn't matter what it is, it just matters where it is. So you got your fan motor, and then we got this little thing here with a coil. All this stuff is back behind. I got to take a screwdriver, and I got to kind of prop this up and pull this off. And now I can expose some of my electrical components, which we have a couple different ones here. We got this piece here. that connects right to the common. And actually, I got to pop the relay off before I can get that piece. So here's my start relay. This is this piece right here, the starting relay. See the coil wrapped around? That's that coil there. You see this rod with the plunger? That's a magnet. And that's the part that pulls up, right, when the power gets to it, to let the power go through to energize the start winding. It just goes down through here like that. I'll draw that out in a minute. But just look, identify the component. This one here is a start relay. There's a couple different ways they can, normally we would do a relay, another circle like the fan motor, and I put SR, and I would put a set of contacts like that, and somewhere else in the diagram I'd have SR. This is a relay with coil. But they have it drawn a different way, because this is really not a ladder schematic. This is more of a pictorial wiring diagram, because it looks like a picture of a compressor, a picture of a motor. The ladder schematic would look like rungs on a ladder. And we're going to convert this pictorial to a ladder schematic after we identify all these. Or we can write it like this, like they have here. So again, make the plunger first. Put a couple of holes for showing the contact points, and then just take that and squiggle it down like that, like an M on its side. And that is the drawing for the start relay. Because we don't need both windings energized the whole time the motor runs. In fact, the start winding has more wraps. Remember finding common start run? You always had a bigger number with the start winding than the run winding. So after we get it going, after that motor gets turned over that first time and she starts to spin, we don't need the start winding anymore in the circuit. And that's what this relay does, takes this out of the circuit. Because actually what's going to happen if it stayed in the circuit and kept spinning, it would overheat and burn up the windings. And that's one of the compressor problems. The start relay didn't kick out the winding, and it stayed energized, and it overheated, and it burned up. The little insulation melted, and it fused together, and then we had a short. Bad compressor now. All right? So the start winding we don't need in the circuit, just the run winding. And actually, the start winding, because it has more wraps than the main or the run winding, it acts like a generator. So you got both a motor and a generator generating more voltage back out of this winding than it's actually receiving. It produces more than it receives. And we'll talk about that in a little bit too. But if it's got 120 volts coming in and it's got it running around that winding, that means it could have up to 150, 160 volts coming out. It creates more voltage. And that's another type of relay. Like this one's a current relay. This one uses the current to energize the winding. Can we stop with the can? All right, this one uses the current. There's another one that uses that extra voltage produced. That's a potential relay. Because think about this. They call it voltage, potential. All right, potential, voltage. I'm going to interchange those words. Or they call it back EMF, electromotive force. What is it? It's motor. What's it running with? Electricity. EMF, electromotive force, EMF. And there's back EMF. And it usually has more coming out off that start winding than what's going in. All right, so then you got the overload. This is the overload. We got the start winding. This is the overload right here. They look different. Some have I showed you one with a disc, a bimetal disc. There's another one that uses current that looks like the bimetal disc one, the round one. And then this is the other type. All right, all that's doing is measuring the heat. When the heat gets too hot, the current gets too much current flowing through the wire, it overheats, pops open, and that breaks the circuit. So that both these windings, they can't be energized anymore if the circuit opens up. So you got the overload protector here, and it looks just like a disc like that. That's their overload. And then that's pretty much it, aside from the compressor itself. And I can draw the compressor like this. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. All right, and this is my common, this is my run, and that's my start, and that whole thing's the compressor. The last drawing that you have for this would be the cap. Now look, it looks like coil. It looks like contacts from a coil, but one's a half moon, like that there. So that's a cap. One's straight up and down, and I'll draw that a little better. Straight up and down. And the other one's a half moon, and that's our capacitor. Or you can just call it a cap. And then there's one more drawing that you'll be tested on here. This is our power cord. So you got your power cord right there. Okay, power cord, plug it in on the bottom. And then this little funky thing off the power cord and a few other areas is our ground. Let me see, I can draw it over here. So that's where they got the triangle with the 3 little lines. That's our ground. So that's where we ground it up. All right, so let's trace it through. Let's see what happens here. I'm going to go ahead and put all this stuff back together. So you don't need to mess with this for the wiring project. All you got to do is hook back up the start relay. Some of them have numbers, but we don't really need it. Look, it can only really go one way. I can't put the start relay and then the overload on because it won't fit. There's a little tooth on the end that sticks out. You got to put the overload on first, and then you can put the start relay on. All right, and then you can put the cover on. You don't even need to take the cover off. That part's already done for you. Like that. One thing with the cover, make sure the wires go through the little slit on the side, and then it comes down, locks in, pops up, and that's it. Okay, done deal. Now, I got 2 wires coming out for the fan motor. Look, they almost match. There's the fan motor wire. There's these 2 wires here. So these 2 are going to be wire nutted together. And then what's the funny thing about these fan motor wires? What's the deal? One's got a groove, ridges. The other one's smooth. Which one is hot?
Ridges.
No?
Smooth.
Smooth. Yep, and the one with ridges is common. All the commons can be tied together. So we can tie the common, all right, to the common one. Let's see which one this is. All right, here's my rigid one here. So I can take these 2 together, the 2 ridges, and use your wire nut and tie it together. Now, if it was a stranded and a solid, you'd have the stranded sticking up about 1/8 of an inch above the solid, and then I can give it, no, that one's not going to be good for that one. Could be a bad nut. Might not have enough stripped off. No, I don't think there's enough stripped off here. Grab me a pair of strippers out of the top of the box, and we'll strip a little more off. I might be able to get this one. Yep, got that one. All right, and then our other fan motor wire connects up to the other one coming out. Thank you, sir. That's it, the fan motor's done. So let's take a look and see what I just did. So I just took one side from the fan motor right here, and let me use a different marker. Let me erase this so it doesn't get confused here. Alright. So I just had this one come up from over here, and what I've done is I found where that wire connection was, and I tied it together with the black. Look, it's after the cold control. It's after the thermostat. The reason it's after the thermostat is I don't want the fan motor running if the compressor's not running. Don't need it. All right, and then the other side comes back through, I'm going to use right down on the bottom here, back down through here and ties right there with a wire nut to the white. So now I just got to make 2 more connections. I got to make a connection for this one here from the white, from the power cord to that wire nut, and that's going to go right to the white that goes to the compressor on one side of the start relay. Look, here's my white right here. That's it. That's all I need. I got to find the one that's, which one is it going to be for neutral? White, common, neutral, same thing. Which one is it? Rigid or smooth? Smooth is hot. Rigid, rigid. So I tie it together. Use the wire nut. Make sure it should be able to hold 60 pounds. It's a small child hanging from that wire nut. All right, that's it. So I got that part connected, and then I'm going to go back here, and we can use this side here, the black, and I'll go up here. Look, number 2, if I had something, a note, that could be for something else. But we're going to go take it up here, and that black goes to where? Where I got to connect that to. That black coming off the power cord. Which one? Where I got to connect it to. What's it going to? The cold control. What's another word for cold control?
Thermostat.
The thermostat. Does it matter which side of the thermostat I use? No, it doesn't matter, because just like a switch, it doesn't really matter. So I connect up the power cord here. There's my power cord. Oh, look, this one's already got a spade connector. So I can connect up the spade connector there like that. And then look, what happens after the coil control? Well, that one goes to right here to my fan, and the other one splits and goes to the overload protector in here. So look, that's this wire, the overload protector. And that's it. Now, if you really wanted to be a little safer, I would have you wire up the grounds. You'd have everything grounded before. But all you need to do is plug it in to make sure, don't touch nothing, make sure it's not touching anything metal. Plug it in and just see if it runs. And would you plug it in like that with the fan down?
No.
Why? What would happen? Yeah, it'd spin all over the place. It could get dangerous. It could cut the fan. So just have it turned up. Make sure the fan free spins. There's nothing in the way. And then just plug it in. What are you going to feel if the compressor's running on one side versus the other? One's blowing, one's sucking. Suction line sucking the refrigerant in. This does not connect it up to the rest of the system, so all it's going to do really is blow out one side and suck it on the other. Alright, and then we've got a video here, man. So, alright, that's that. Now look, pictorial, the legend. Now, let's take it and convert it to a ladder schematic. So on the back of your paper, you're also going to draw up a ladder schematic. We're going to convert some of these over to a ladder diagram. And look at the ladder. The ladder's going to be, look, this looks confusing. The ladder's going to be real easy. You got your black and your white down here, and they're telling you the colors you're going to use. I'm going to call it, instead of black, L1, but that's black, okay? And then over here, I'm going to go multimedia on you here. L2, that's going to be my white wire. I'm going to draw it in blue, okay? Between the two, typically, we have between here and here, 120 volts. Draw that a little better. So here's my wires coming down. L1's coming down like that. So between that wire there, if I was to read with a meter, I should have 120 volts and some change. And then let me get the blue one going straight down. Now, that's these two wires here. So I'm going to go ahead. We'll do the black first. So I'm going to take the black one. And what do I got? I got nothing to the cold control. So I'm going to go ahead and go right here and we'll put in the cold control. So I'm going to go down like this and then we'll put right here like that. Let me draw it, drop on temperature drop. Put it the right way. That drawing's a little off. Boom. So there's my thermostat. And then what's the thermostat controlling? It's two different things. I got my compressor here. And then I got where it comes down, and it's got my fan motor here. All right, and that's going boom right to this. And actually, oh man, I got to draw something else before. Once we get inside the compressor, I got to draw this overload. All right, that's my overload right there, the little disc. And then we can tie this to our two windings. 1, 2, 3, 4, 5. Boom. 1, 2, 3, 4, 5. Let's do 10 here. Okay, top one's only got 5. This is my common. What's the top one going to be with the less? The one with less. It's going to be CSR. What's the S for? Start. And what's the R for? Run. Which one has the less numbers? Run. So the top one's going to be run, and the bottom one's going to be start. All right? And then they got the relay, though, coming from the white side. So the white side's got a break with a relay. Let me get that in here. I might need a little bit more room, so I'm going to take this one over a little bit. All right? So we got, first off, the white one going to the fan motor. Goes right to the fan motor. Boom. So I'm going to go ahead and just do this one like that. And then this one right here, it's going to have the plunger. And then it goes to our windings. All right? Boom, boom. Just like that. That's it. All right? Goes right to that. And then actually I got to draw something in between here. Hold on, hold on. Yep. Goes through here. Plunger there. Number 11, right to our start winding. So that's that one there. Boom. So this breaks the start winding. The other one came up right here. I'm going to do this in a different color. And this is my coil. And then it goes to run. So that's incorporating this particular style. Now normally I draw it a different way, but that's the way this is it. And that's it. That's the wiring diagram. This is this wiring diagram right here, but it looks like rungs of a ladder. Alright, if I had another load, if I wanted to put this heater stuff up in here, I could put this heater stuff up in here in a ladder diagram like this, and I'll do the heater stuff in red. So we'll add the heater stuff, which is again, we got our red, which is going to be our hot. Alright, and that goes to a toggle switch. And then it goes through a fuse. Alright, there's our fuse. And then it goes through a manual limit reset. And the button goes up like that. And then it goes through another thermostat. And this one opens on temperature rise, so it'll be above like that. And then it goes to our heater. And then, from there, common ties right back. And that's it. So now I've converted this. This is now the ladder schematic for the pictorial. All right, this is better to use for troubleshooting, because this kind of gets confusing, trying to locate all this stuff up in here. But if I didn't have power at my run winding, maybe I lost my connection between here and here, and I could see that. So what do I have to do? Well, if I don't have power to my run winding, all right, on my compressor, well, that means I got to take this out here, take my start relay off, and I want to find the coil, which is right here, and the coil ties on one side right here and one side right here, and I should read a resistance value with the meter here. All right, and if I don't, this coil's opened up somewhere, and I've got a bad relay. I got to change it out. Well, let's say the start winding, it's not turning over, it's not getting power to the start winding. Well, maybe this relay's not pulling the magnet up, right? Maybe it's not pulling the magnet up and letting the power go through. Well, how can I test that? Well, with this one, you hear that shake in there? I can put a meter here, measure for ohms, and then if it doesn't have any ohms, turn it over. And that'll simulate the magnet being energized. And now I should hear it tone. So I can test this relay a couple different ways. What kind of relay was this one? Because there was two. One was potential, that used voltage. This one uses something else. Amperage. What's another word for amperage? No, ohms is resistance. Ohms is what we use to test it. And I can only test it when it's isolated from other components. In other words, it can't be plugged in. That's a fancy isolated from other components. That's fancy talk for it's disconnected. Same thing with the fan motor. I can't test the fan motor resistance with it connected up to other components, because I'll get the resistance of this, I'll get the wire. You got to have it isolated to test out the resistance for the fan motor, which means, oh man, I got to take the wire nuts off and undo it. And voila, that's that there. And then I could isolate it. Now, isolated from the other components, I could read resistance that way. But I'm not reading resistance. So I've talked about potential voltage. This is not a potential relay. This is a different relay. Amperage. What's amperage? What's another word for amperage? You got to know all this terminology. If you don't, you won't have any idea what I'm saying when I talk to you. I said, get the amp probe and go measure this. What's the other thing we're missing? You got amps. All right, that's the thing you're missing. The other term for amps, what it's measuring. And you got voltage, it's measuring potential, electricity, energy. And then you got resistance, that's measured in ohms. But what's amperage? It's amperage. Current. Current. This is a current relay. Current relay. And the other type was? No. Amperage and current, same thing. Voltage and... No. No. Resistance and ohms, only with no power. Has nothing to do with these other two. Current. Voltage, yeah. What's the other terminology I use for voltage? I gave you two. One was abbreviated EMF. What was the EMF? Electromotive force, yes. And then what's another word they use? It's not, kinetic energy is when it's already moving. Right here, I don't have kinetic, I got the other type. Potential energy, yeah. So I have the potential to plug something in, potential energy, and once it does start working, then it's kinetic energy. Yeah, you got to think about your science stuff. Potential, EMF, electromotive force, voltage, all those are interchanged together somewhat. amperage, current, same thing there. Those are interchanged. And then resistance in ohms is another thing. Altogether, Ohm's law. Remember, it takes 1 volt to push 1 amp through the resistance of 1 ohm. That's the Ohm's law theory. Any questions about this now? So I can give you a quick test. You're going to put that paper away. I'm going to give you the quiz again. See if you can remember all the controls. And that's pretty much it for the... Now look, same thing. It's all in here. If you can master this, you can master the basic electrical wiring diagram for most refrigerators. Instead of a heater, though, they might add a light with a push-button switch.